We'll go ahead and get started here. Thank you for joining today's webinar, Unlock the Power of the ZFS Storage Appliance. To start, I'd like to do a quick introduction to Charles Kim and Viscosity. So Charles Kim is our founder and CEO of Viscosity. We started about 6 years ago in 2011. He is an Oracle ACE director. He is currently the president of the IOUG Cloud Computing Special Interest Group. That his blog site is on there as well. He is an Oracle ACE director, Oracle certified DBA, certified Exadata implementation specialist. He's authored over 10 books and has over 25 years of Oracle experience on mission and business critical databases as well. I'll run through a quick intro to Viscosity. So basically, we're a solution-based consulting company that specializes in Oracle technologies. We do have over 4 Oracle ACE directors as part of our management team, and we've written over 20 books in this space, ranging from performance tuning to the Exadata handbook that's on here. We have various offerings all the way from software and application development in the cloud, professional services, and license management to database zero downtime migration. So with that, I'll go ahead and pass it to Charles.
All right, thanks, Callie, for the introduction. Thank you, everybody, for attending. I know it's right after lunchtime for those who are in the central time zone. The content and the abstract for this webinar kind of morphed a little bit over time. Initially, it was purely focused on doing a why does ZFS make such a powerful tool, powerful storage, leveraging Oracle technologies and against Oracle databases. And as the weeks passed by, I was asked to add more of the non-Oracle solution flair to the presentation. And as of last week, the new version of the ZFS, ZS 7-2, midline and high-end appliance was announced. And so as a result, I changed up the presentation even more. And so today what we're going to talk about is initially talk about what the new storage appliance offers in terms of capacity, memory, and performance. And then also talk about the new features of OS 8.8.0 that actually ships with the new storage appliance. And then go through a solutions for non-Oracle workloads on the ZFS, and finish up with a little demo, both command line CLI as well as the GUI itself, the browser user interface. To start, as you can see from this slide, there's a focus on Linux and Linux and Solaris. And the reason being is that obviously those two operating systems are ideal candidates for NFS, for the network file storage, file system that is. And also, you'll also see right next to the Linux and Solaris recipes book, the Exadata book. And in that Exadata book, we have a chapter on ZFS, in particular on how to leverage the ZFS for Exadata, how to tune the ZFS for Exadata, and how to perform backups on the ZFS for the Exadata. At Viscosity, we also have a white paper that we published back about 4 or 5 years ago, and it's called Exadata and ZFS, the Perfect Marriage, and it's available for download from our website. So please feel free to visit our website and download that white paper. And in fact, we get a lot of technical consultants downloading that white paper, in particular for reasons of how do I tune Linux for the ZFS storage appliance. Another book that we're working on this year, and which will be released in either 2019 or 2020, is going to be Linux recipes for SQL Server DBAs. And obviously, the ZFS storage appliance works really well on the Linux operating system, Solaris operating system via NFS, and also via as a block storage or iSCSI, but it also works well on Windows as well. And so on Windows, it supports iSCSI protocol as well as the SMB protocol. And so For all the latest and greatest Linux tips, go to dbexpert.com/dbi/Linux. That's my own personal website, and I'll blog there on a regular basis. Let's talk about the agenda. So like I said before, the agenda has shifted and morphed a little bit. We probably won't have time to talk about ZFS for Oracle workloads, and that's actually it's actually intentional. We want to focus on what's new with the ZFS, ZS7-2, and obviously the naming has changed a little bit, and also talk about comparing this new model with a previous model, the 5-2 and the 5-4, and then we'll go through the new features of OS 8.8 that ships with the new ZFS, and then go through various solutions and scenarios for ZFS for the non-Oracle workloads. All right, so the ZFS, this is the 6th generation of the ZFS, and the ZFS 7-2 was announced last week, and the naming changed a little bit. And now it's no longer called 5-2 or 7-2 and 7-4. Now it's the mid-range or the high-end model is what they're calling it, okay? And so from it, we have also the rack system as well. And the rack systems are pre-configured and pre-racked, and it's also tested at Oracle before it ships. And I'll go through that a little bit more in the future slides. Okay, so from a improvement perspective, it is still the same 2RU form factor, but however, we have more memory bandwidth per core. The SAS3 connectivity doubled, and also from an IO expansion perspective, we have up to 10 networking adapters now, and which yields 2.5x in terms of more network connectivity throughput. Also, from a IO bandwidth perspective, we have have increased port density, and as a result of it, we also have additional 10 gig ports for Ethernet. And what's new with this particular release is now they have released a 32 gigabit fiber channel, and it's a dual 32 gig fiber channel as well. If you look at the top right-hand corner, the last day to order the ZFS 5 series is going to be end of February, and we are now pushing heavily on the X7, effective, in fact, this week. If you look at the mid-range series, we have 66% more memory bandwidth now, 46% more IO bandwidth, 33% more memory, et cetera, but we have 2.5x more 10 gig E and 25% more on the 40 gigabit as well as InfiniBand. You will see a slight increase in the price of the mid-range, mainly because there's an increase in memory configuration. On the high-end series, which equates to the ZS 5-4 replacement, right? You're gonna get more CPUs, more cores, and with it, less memory bandwidth, but more per core. And we'll also see the same as before, 1.5 terabytes of memory per controller. However, for the rack systems, right, we're gonna see a slightly lower price, mainly because of the solutioning that Oracle has put together. So let's talk about the rack system, okay? So like I said before, the rack system is fully tested, it's pre-assembled at Oracle, and with it also comes free licensing, replication, cloning, and encryption. So if you were to purchase the ZS 7-2 midline or the high end, and you wanted to do replication from one ZFS to another ZFS, what they call remote replication, you'll have to actually buy that software. The same with the cloning. If you wanted to go into a snapshot clone, right, you'll have to actually go buy that licensing. And also from an encryption perspective, the same exact thing, you have to go buy. And each of the components is roughly about 15K. So there's some additional savings there as well, okay? And so the idea with the rack system is that we're going to reduce your risk and we're going to increase your TCO, optimize performance, and also if you are leveraging the ZFS, in this case, to back up an engineer system, such as Exadata or Supercluster, the Platinum support services are actually included as part of this, the price as well. And so that's another big value add. All right, so from a ZFS 7-2 perspective, right, you know, automatically you get the hybrid column compression, right? So with ZFS, we have the option to enable compression at the share level, but if you're running an Oracle database, you can leverage hybrid column compression, and instead of getting 2 to 3x compression that you would get in the ZFS, you can get it up to 10 to 50x compression with the hybrid column compression. Also, with ZFS, we also have a what we call OISP, the Oracle Intelligent Storage Protocol, and this is on the 2nd generation as well as the advanced data optimization. And this is only available for Oracle databases running 12C or higher. And we will not, my goal is not to cover any of these topics, because those topics alone, I can go for a full hour, but we're going to focus strictly on the benefits of ZFS, okay? And so also with the ZFS, we have extreme low latency InfiniBand, 40 gigabit. This is what makes ZFS super popular with the engineer systems. Instead of talking about throughputs in millisecond, now we're talking about throughput from a networking perspective in microseconds, okay? And so also new to this release is 32 gig E HBAs, right? And so now we're talking about ability to do fiber channel and to be able to get that extreme performance, okay? And so also, we're gonna get 2.5x increases in the 10 gig E. And also from a fiber channel perspective, we're looking at 67% more IO card capability, okay? And so from a controller perspective, we can have up to 3.8 petabytes of all flash and 15.5 petabytes of disk capacity. And from a raw performance perspective, right, this actually will translate to up to 48% more performance than the previous release. And this is where a lot of people are gonna love the X7. All right, so if you compare the 7-2 directly to the 5-2, the mid-range, you won't see much of any kind of changes, especially when it comes to amount of flash storage, DRAM, processors, and or flash cache. And so if you compare the two columns, they're almost identical, right? Now, if you go to the 7-2 high-end compared to the 5-4, you will see differences in the flash storage, right? It was 2.4 petabytes on the 5-4. Now we're at 3.6 petabyte for the max. The maximum DRAM cache is still the same. However, from a processor perspective, right, we're going from 2.6 gigahertz down to a 2.1 gigahertz. So we're going to a slower processor. However, we're getting 6 cores more per CPU. Okay, so that actually translates to 24 more cores and thus the additional performance. Okay, from a reflash cache perspective, right, we are still at 614 terabytes of reflash cache, and that reflash cache will directly translate to our hybrid storage pool that ZFS is so popular for. And so we have 3 types of memory and storage on the ZFS. First is DRAM, and the second is the flash, the solid state, right? And then obviously you have disk. So if you look at the disk perspective, we measure performance in disk in milliseconds. When we measure performance in flash, we measure in microseconds. And when we measure performance in DRAM, right, we measure performance in nanoseconds. So as you go from DRAM to flash, you're talking about, 1,000 times faster performance. And when you go from flash to disk, right, you're talking about 1,000 times again in terms of performance again. Our goal is to service 90% of the IO in DRAM, right? And so Oracle has this concept of a hybrid storage pool. And in it, we have at the highest level what they call adaptive replacement cache, ARC. And so all reads and writes will go through the ARC, right? Also, they have what they call a level 2 ARC. L2 arc, right? And this is where the recache is composed of. So if you look at our previous screen, right, reflash cache is up to 614 terabytes, right? DRAM on the ZFS can be up to 3 terabytes, right? So we can service all of our reads through DRAM and also through our, which is ARC, and also through our level 2 cache or level 2 ARC through the reflash cache. However, when we do a synchronous write with an S, right, it goes through the ARC, and ARC will actually bypass that to the synchronous, to what we call the ZFS intent logs, right, the ZIL, which is much like the redo logs that we have in the database, or the logzilla is what they often call it, right? The synchronous writes will go directly to the SSDs, right? And over time will get flushed to disk itself. And so through this series of storage pools and how the algorithm works, our goal is to service all IO, 70 to 90% of all IO through the DRAM itself. All right, also, there was a benchmark that was done as part of this release by the Standard Performance and Evaluation Corporation. And basically what they did was they induced load. This is the same spec benchmark that they run for the processors as well. And in this benchmark, they were able to sustain 6.4 gigabytes per second with only 3.85 millisecond latency, okay? And so with an overall response time of 0.78 milliseconds. Okay, so if you also look at what's highlighted in red, right, they were able to sustain basically 5.16 gigabytes per second, right? And still be able to sustain that IO with a less than 1 millisecond throughput. Okay, so it's from a benchmarking perspective, it significantly outperformed any of the other competition. So from a scalability perspective, right, on the ZFS ZS3, right, the 3 terabyte DRAM cache is still the same. The 614 terabytes of reflash cache is still the same. But however, the amount of flash storage, reflash storage, the amount of flash storage is at 2.4 petabytes. And now from a hard drive perspective, we can go up to 9 petabytes as well. With the ZFS, we can also provide a hybrid cloud solution. And so in Oracle Cloud, we have this concept of object storage. With object storage, think about as hard drive space in Oracle Cloud. And we also have archival storage, which is like tape in Oracle Cloud, right? And so leveraging what we call the Oracle Storage Gateway, we can actually mirror and replicate storage that we present on the ZFS to Oracle Cloud. And so basically we download a Docker container from Oracle, and we install that Docker container on a Oracle Linux 7.x environment, and we basically stand up a container that serves as a local presence of Oracle Cloud in the form of a NAS device. We create shares, and we mirror that share to Oracle Cloud by providing credentials for our object storage. And so basically the object storage will point to the REST endpoints to Oracle Cloud, and we will mirror the NFS share to from the ZFS to the storage gateway, and it will replicate across to Oracle Cloud. We've been waiting for what Oracle was calling the cloud storage pools for a while. It was announced originally in March of this year, and I personally was hoping for that to be released with this version of the ZFS, and it still isn't quite there yet, and so we're still looking forward to the cloud storage pools. But until then, our solution is to go leverage the Oracle Storage Gateway cloud service and replicate to Oracle Cloud. right? So from a backup perspective, right, we can back up anything to the ZFS. Obviously Oracle databases, but also SQL Server databases can be backed up, NoSQL, DB2, Mongo, any kind of application, right? From eBusiness Suite, SAP, even Microsoft applications like SharePoint and Exchange, any kind of virtualization stack, VMware, KVM, Oracle VM, just about every virtualization stack can be backed up to the ZFS. And there's numerous vendors out there that have built-in direct hooks to ZFS, Veeam, NetBackup, Networker, Commvault. They have integration points to the ZFS to be able to back up numerous other files to the ZFS as well. All right, so in the ZFS, we have multiple levels of data protection. Obviously, the most popular is to mirror our drives, but on the ZFS, we have the option to do double parity and even do triple parity on the ZFS. So, you know, our data volumes are growing exponentially, and our hard drives are getting bigger each year, right? So even though our hard drives are almost doubling or have been almost doubling for a while, the size, and they're not doubling at the rate like they used to, but they're still going from 3 terabytes to 5 terabytes to 8 terabytes to 12 terabyte drives and whatnot, right? But however, the performance has not kept up at that rate. And so for us to resilver a hard drive from corruption or from a failed drive, it can take us hours to resilver a 12 terabyte drive, right? And so what was originally popular was only as double parity. Now what's getting more popular now is the RAID Z3. And so the idea is to reduce exposure of failure during the resilvering process. And so when it's resilvering as a result of a bad drive, because every drive has a mean time to failure, and when that's happening, will still give us the protection of a double parity. And so the RAID Z3 is getting more popular. However, for production workloads, the recommendation is to still mirror your hard drives. So also in the ZFS, we have numerous levels of compression as well. If you go and see what's highlighted in red, we go from gzip, which is a default. And from there, as you go up, gzip2, which is faster, and all the way to LZJB, which is the fastest, right? So you go in that mode. However, as faster you go, the less compression you're gonna get. And if you look at the very bottom, the gzip9, right, is the best compression that you can get. However, it's going to be the most amount of CPU consumption to do the compression. What you also see is here is the deduplication. Notice where it says warning, right? So we basically for database workloads, we do not dedupe, right? For regular files and whatnot, we can actually enable deduplication. But for databases, we leave that disabled. Right, so also, like I mentioned before, if you are backing up database, engineered systems, supercluster, Exalogic, Exadata, right? The Platinum support is bundled in. Also, with the ZFS, we want to implement what we call the ASR, the auto service request. So basically, it's a mechanism for Oracle to phone home and for Oracle to automatically create service requests as it identifies failed components, disks, controllers, right? And it'll actually create a service ticket and a field engineer will be dispatched, okay? From a licensing perspective, right? If you do not purchase the racked systems, right? Cloning, remote replication, and encryption are additional costs. Okay, I'm gonna just go through these real quick here. Let's go through the pertinent 8.8 features, okay? So what you see highlighted and bolded, I actually will have screens. I'll actually go through some of this, but with this release, we can have Active Directory credentials at the administrator level, be able to log in to the ZFS, leveraging 80 credentials. Now with 8.8, we have the capability to throttle throughput for file systems. And so this throttling is not IOPS, it's pure throughput. So we can throttle reads per megabytes per second for reads and megabytes per second for writes. Also with this release, we can set up LDAP server preferences. Previously, it was in round robin fashion, but now we can actually go specify, this is my preferred LDAP server, and then have secondaries and tertiaries as well. Because the ZFS was basically born in the cloud and enhanced in the cloud, it has full REST 2.0 support, and even login tokens are enabled as well. So I can actually go in and grab a REST authentication token and be able to log into the ZFS without being prompted for a password. Okay, and we'll also go through the other enhancements like scrub scheduling and storage pool encryption. Okay, so this 8.8 release is available in the older releases, right? Even down to the 7420s and 7320 models. And so even the older releases can benefit from things like the IO throttling for file system, which is what some of our customers have been waiting for a while. Okay, so let's talk about scrub schedule, right? By default, the scrubbing happens every 30 days, right? And basically it's to resolve data consistencies, right? So we want to automate as much as possible. And in general, we want to do it more often than 30 days, right? And our goal is to find data inconsistencies over time and identify bad blocks before it becomes disk failures, and thus improving data availability. Like I said before, from an IO throttling perspective, right, you can see that we could limit, let me see if I can pull my pointer here, I guess not. We can limit both reads and writes. By default, it's unlimited, but as we have and store, multiple applications on the ZFS, we want to be able to contain ourselves from noisy neighbors. Also with this release, we can actually set up encryption and force the encryption for all projects and incoming shares as well. With each project and share, they can have their own encryption keys, but we can actually force transparent data encryption at the ZFS. Like I said before, Oracle Cloud heavily leverages the ZFS, and now we are at 1.4 exabyte usage in Oracle Cloud. And because it is managed in Oracle Cloud, right, all the RESTful APIs that's available in the cloud will slowly be available in the ZFS as well. So ZFS supports REST 2.0 APIs now, and now we can even do REST login tokens. The LDAP capabilities, right, it's no longer round robin, but we can set preferences. And if the first server goes down for some reason, the second server is picked up. And if the first server comes back online, the first server comes back in the search order. The authorized AD users now can log into the appliance and even be the administrator as well. So DTrace is one of the most powerful things that's available on the ZFS. And so for customers who are on VMware, we recommend that we monitor both with DTrace as well as the XSTop. And so with DTrace, we can monitor end-to-end all disks, hard drives, as well as flash, the controller CPU, the network layer, the ARC cache, and even at the VM level, right? So if you look at the right side, as you see all the metrics, we can actually go monitor across all those options. And so the whole idea with the with DTrace monitoring, right? We want to know who's sharing, who's using the shared resource, and how are others impacting each other. Also, with the ZFS, we have the capability to service or provide service level agreements. And from SLAs, we can actually set SNMP traps that say, for a given NFS, if the response time is greater than 3 seconds, for example, right, we can have sent emails to the administrators, or and even turn on additional tracing capabilities so we can get a better understanding of what's going on. The snapshot cloning capabilities of the ZFS is one of the most powerful features that it has. And at the share level, I can actually enable or create a snapshot. And once I create a snapshot, I can create a clone right off of it. And once I create a clone, that clone becomes a share. And I could actually share that out to different hosts. And so here, as part of the cloning options, right? Just like I would do for a share, I just provide a name and a mount point, and I'll be able to share that across. Okay. Also, I can schedule my snapshots. So instead of doing manual snapshots, I can schedule a snapshot to happen every night, or I can actually have it happen every month, right? And so this kind of situation, the one that you see here, is where we take one at 2 in the morning every night and keep it for 31 days. And we do another level of snapshots. We take at the first of the month, right? We take snapshots and we keep it for 5 months. Okay, so now let's look at some of the use cases and why people would use ZFS for non-Oracle workloads. Okay, so last year, I had the opportunity to go to Wellington, New Zealand as part of the Oracle ACE Director Tour that covered New Zealand and Australia. And when I was in Wellington, I visited the Weta Digital studios. And when I was there as part of the tour, they actually mentioned that they heavily leverage Oracle. And with some interest, I looked up what they were talking about and found out that they were heavily invested, and they are a referenceable customer for the ZFS platform. And so the Weta Digital Studio, they're known in the industry for all their special effects, animation, and imagery. And obviously they did all the Lord of the Rings, King Kong, Avatar, and the Jungle Book. It was originally founded by Peter Jackson, but now it's independently operated. And so the Weta Digital, they actually saved a lot of money, and they're very happy with the ZFS. And so for what they did was they were able to eliminate the cache filers that they had, and came to the realization that ZFS can actually satisfy all of the reads during their peak times. The ZFS provided high performance and yet with extreme low latency. And it allowed them to consolidate their filers. And by consolidation, they were able to reduce their footprint in the data center, thus resulting in substantial savings at the data center. And so from there, I also looked up what are the other use cases for the ZFS, right? And so the ZFS seems to be very popular in the media and entertainment industry. And in particular, it seems to compete with Isilon. And the latest Isilon release compared to the ZFS release, the ZFS is substantially better in performance as well as capabilities are some of the reviews that we see out there. And so from a media industry perspective, right, the hybrid storage protocol, right, we're again, right, able to service up to 90% of all the reads right out of DRAM, right? By implementing and adjusting the record sizes, we can actually handle 4K media content on the ZFS easily. And also with the 40 gig Ethernet capability that the ZFS provides, we can also service 4K media content over the network as well. And obviously for InfiniBand, we could even go even lower latency. And and with the low latency capabilities, right, the non-linear editing comes right out of the DRAM cache as well. And so with the ZFS, we could set up the block sizes to be up to 1 megabytes, and thus enhancing our streaming performance, which all results to higher TCO and lower cost. So from a ZFS perspective, right, it becomes an ideal storage to run virtualized workloads. And this is not just for Oracle VM, but also for VMware. And it's not just for Oracle, but it's also for SQL Server, and as well as Hadoop. And so we can run virtualized Hadoop, and that's becoming more and more popular. And as well as virtualizing non-Oracle or non-relational databases as well. Okay, so we have 2 white papers that are highlighted here. The first one is obviously best practices for virtualizing ZFS, VMware on ZFS. And the second white paper is how Oracle deployed 10,000 VMs on the ZFS. This is VMware VMs, that is. Okay. Also, SQL Server, running SQL Server on ZFS is also a viability, and there's a white paper that Oracle wrote on that as well. And however, right, now with the 32 gigabit HBA capability and fiber channel, right, we can actually service an enormous amount of IO for SQL Server databases. So some of the best practices for SQL Server, right, we want to be able to leverage DRAM as much as we can, right, but place tempDB on its own volume. Do not set auto growth or auto shrink for the database. Never use thin provisioning for production environments. And as a general rule, don't exceed 90% capacity. Obviously for large volumes in the multi-100 terabytes, right, you can go up to like 95%. For data warehouses, set the synchronous write bias for throughput for data and latency for logs, and set the block size to be 1 meg. For OLTP, set the synchronous right for bias for latency for both logs and data, and set the block size to be 512K. And so these kinds of best practices are available for not only SQL Server, but also for big data as well. So from a Cloudera perspective, right, we typically triple mirror all of our data across every node, right? And so by leveraging the ZFS, we can actually reduce the replication factor by 2x, and at the same time, reduce our storage consumption and by a factor of 2x, right? And by doing that, we also increase the number of copies that we can provide by 4x, and by leveraging compression, we can actually save a space there. And by leveraging mirror pools for the databases, we can provide additional level of HA and protection. And by setting read and write cache, right, we can actually decrease IO response time significantly. And so with dual heads and with fault tolerance, and by setting RAID 1, right, and without not setting RAID 1 without any overhead to the Hadoop cluster, we provide not only higher availability, but higher scalability. So also the white paper that we showcase is for, it's actually by another Oracle partner, but it's has the settings that they used for achieving and setting up big data on Hadoop, on ZFS. So also for MySQL databases, right, you can run them on ZFS as well. You can eliminate the network overhead by implementing InfiniBand, and obviously again with the 32 gigabit fiber channel HBA capabilities, we'll be able to get even more throughput as well. We set log bias to latency like we did in the other examples, set the access time to false, set our record size to be 16K, and for redo, set the record size to be 128K, and we mount the ZFS with the following options, ZFS options that you see there. And we set the numerous NODB parameters as you see here. And again, there's a white paper that talks about what best practices for leveraging MySQL on ZFS. Okay, and so here, I'm gonna go do a little demo so that you can see what ZFS looks like from both command line as well as the buoy. And so the buoy, I'll start from the buoy. Buoy is like our web browser interface. Here we go. This is what the buoy looks like when you first log in. Not when you first log in, but after time. So we can go through numerous menu options. You have the option for configuration, maintenance, shares, status, and analytics, right? And within the configuration scheme, right, we can actually look at the storage, right? You can see that I have a storage pool called ATP. I have 58 gigs of space and 11 gigs for reserve, and I have 5 gigs that's set for spare, okay? I can go look at the network itself, right? I can see all the devices and data links that we've provided. And from a maintenance perspective, right, you can actually see from the hardware to, like, for example, the logs, right? What are all the log messages that I've been getting? You could also look at the problems, right, that it's reporting. But in the logs, because I'm going to show later that there's alerts that you can see, right, as well as audits. Everything that we do is audited. I'm going to show how we get to this exact same thing via the command line as well. Okay, and shares is what's really important that I wanted to demonstrate as well. So share, I've created 3 shares here, one for the backup, one for the data, one for, in this case, a clone that we did. So if I double click on the backup itself, right, I can see that I've set the bandwidth limit to be 400 megabytes per second for reads and 200 megabytes per second for writes. That's what we showed earlier in our example, right? And in this case, I've inherited from the project. So from a best practices perspective, we always create a project, and under the project, we create our shares, okay? And so this backup 01 share, right, is what's being presented to the hosts, okay? Also, at the share level, I can go look at snapshots. And what you see here is I've got 1 daily snapshot and 1 monthly snapshot that's automated. And I can take I've taken a manual snapshot of the daily backup itself here as well. Okay, and so this shows us snapshots, and we could actually replicate between one ZFS to another. Oops, that's the wrong one. Let's do this. This is the command line interface to the ZFS. And what I'm going to do is I'm going to show you a couple things. Is earlier I showed you the audit and the alert, right? So if I type ls, you can see that there's analytics, configuration, maintenance, raw, share, and status, right? And so I'm going to go under maintenance. I just type in maintenance, hit tab, okay? And go to doing ls, you'll see logs, right? And type logs, right? And here, I can see alert or audit. In this case, I'm gonna say select alert, right? And the alert message that we saw earlier is also right here as well, okay? I can go ... look at the audit as well, show audit, select audit. Okay, everything that we do inside of the ZFS is audited. So we can actually see that I actually increased my read limit for the share, and same with my write limit as well, or actually set it, right? And it was set by root, it was set from this IP address, okay? I'm gonna go show you also the shares that we did as well. Okay, I'm gonna go cd/, okay? I'm gonna do ls, notice that there's shares. I'm gonna just type shares, okay? I'm gonna go and, if you look at the very top, right, you'll see that I have new projects. I have the Oracle project here, right? So I'm going to say select Oracle, and it is case sensitive. So if you go back and see, if I type with a capital S, right, Oracle, it fails. If I say select with a lowercase Oracle, it also fails. But however, if I put select Oracle with the little case s, right, then I should be able to get into my project, right? And you could also see that at the project level, we have all these properties. And so if you set properties at the project level, right, all the shares automatically inherit those properties, okay? Now in this case, we're gonna go in and we're gonna go select the backup, because that's what we've been modifying, right? That backup share. As you can see also, it has its own set of properties, okay? And so here, I'm gonna look at the snapshots because that's what we actually did earlier. But before I do that, I should be able to see that my read and write is set to 200 megabytes per second. That's what we saw on the GUI, the browser user interface. I'm gonna go in here and look at the snapshots, right? I say CD, I just type snapshots. And it is like Linux in many ways, and I can actually go SNA, hit tab, and it'll finish typing that out for us. I can type ls, right? As you see earlier, we have 3 snapshots here as well. I can actually go into select on the daily backup snapshot, right? And this is what is done for me. I did a one-time backup of it, okay? I can go again and do a select on the auto, and these autos are the scheduled snapshots. Whoops, I want to type like I'm typing in Linux, right? And it's auto set to true, and it's part of it goes into the storage pool right here, okay? And it's also hidden because of the dot in front of the auto, okay? Also, it can actually look at the network interfaces as well. If I type cd/, it'll take me to the very root, right? And I can go into the configuration itself. Again, I'm thinking I'm in Linux. Configuration, right? And then I can also see from here, go to the net to see how my network is done, right? I can go and type in interfaces, right? Interfaces, right? Interfaces, right? And I can actually see that I have only one interface because this is a virtual machine, okay? I could also look at my routing as well. This is where if you're doing a lot of security, right? And you want to go and enable NFS for a specific host and a specific a subnet and even a port, right? This is where you would go and do all your routing, okay? And obviously, you can do everything through the web, but doing it through the command line sometimes gives you a lot more flexibility. In fact, most of the stuff that we're doing here, you can do through the web, but for command line folks like myself, I still prefer to do everything through the CLI. And so I wanted to give you a brief overview of what it looked like from both the graphical user interface as well as the command line. And I apologize that we kind of had an issue with the UI. So with that, I would like to thank everybody for attending my session. And if you have any questions, please do not hesitate to reach out to us. All right. Thank you very much.
Thank you again, and we hope to talk to you soon.